Okay, so I call this homework 1, 2, 3, 4, 5, 6. It's mixed practice. It's a lot of things that you are supposed to know from your pre-algebra work before you entered our class. I want to go over a little bit of how to do some of these problems. First is this number line work that we have here, 55 and 49. What we want to do is we want to point at the number that is further to the left on the number line. Some of you might be dyslexic. Further down the number line if it's vertical. So if we were to look at it on the number line like this, here's 0, and then I place my 55 somewhere, and the 49 is to its left, right, lower down. Then on the number line vertically, if 0 is here, the 49 is below the 55. And you point to the one that's lower down on the vertical number line. So this is called 55 is greater than 49. That's a sign with a tight point at the beginning called less. The second word is than. This is one that's got a wide opening first. That's called greater. The second word is always than. And then equal, where the word is equal to if they are equal to each other. So now we get to -4 and -7. On the number line, flat, a lot of people would say, well, the first thing I see is -4. And where's -7? It's further to the left. Okay, but if you're thinking vertically, here's 0, and we're doing numbers. Here we've got -4. I kind of put it halfway down. So then I have room above and room below to plot in the -7, which is further down. The one that's further down is -7, so I'll point at that, where -4 is greater than -7. That means it's better to owe someone $4 than to owe them $7. Here, it's better to have $55 than it is to have $49. Now this one, where we have -6 and 4 on the number line, we have our 0 here. 4 I'm going to put about halfway to the right in case I have to go to the right or to the left of it. And then the -6 I'm going to put on the negative side. I don't even have to draw it to scale, and I certainly don't need every number in there along the way. Vertically, what would this look like? We've got our 0. We've got a -6, so I'm going to put my 6 below. We've got a 4 that's positive. I'm going to put my 4 above, which is lower. The -6, which is saying -6 is less than +4. It's not saying that 6 is a smaller sized absolute value. It's saying -6 is worse than +4. It's worse to owe someone $6 than to have $4. So even though 6 is a larger number, it does not get to be the greater value, the better situation. You want to point to the worst situation and open up to the better situation as far as bank balances go. And I'll use that type of language throughout the course. A bank balance is positive or negative, and we can help ourselves decide what's going on. But some people will find the positive and negativeness and all that goes on in the number line to be helpful. But what you do is put down 0 and place this on your number line, and then place this in the proper location, dealing with the first number you laid and the 0, and then you can see which one is further up or down the number line. Vertically, up is greater, and down, lower is worse. So a lot of people will like to do it that way. 55 is greater than 49, -4 is greater than -7. It's kind of like this is less bad than this, and sometimes that's where we are. And then -6 is worse than +4. Okay, and that's -6 less than +4. Here we have 88, 721, and 65. What we have to do is stack these numbers by columns, keeping place value. Watch out for ones, they're skinny. Don't let them get too skinny and jam up your columns close together. So we like to have what we call fixed width of our columns. First number I have is 88. Then I have 721. The best way to lay it out is from right to left. The 1, the 2, the 7, the 1, the 2, the 7. And then 65, lay the 5 and the 1s and 6. That way you don't have to worry about that. I put the 6 in the right location because you anchor it right there with your last digit, which is the units. This is units, tens, hundreds, and let's see what we get when we add. We actually don't add 3 numbers at a time, we add 2 at a time. 8 plus 1 is 9. Take the 9 and add 5, and that gets you 14. So you put the 4 here, and you can write the 1 as big as the 8 if you want. A lot of people write it smaller, but if there's room up there, you can write it. 1 plus 8 is 9. 9 plus 2 is now 11. 11 plus 6 is 17. Not just 7, but 17. And then that 1 and 7 will get me 874. That's how we add numbers in columns. Now up here, we get our subtracting. With subtracting, we can't keep stringing them. because we have to do the subtraction of the terms, using the terms to do the work of the subtraction, what we have here is we have 4, 4, 3, 7, 3. And now I should lay this 1582, 1582 by placing the 2, then the 8, then the 5, and then the 1, so that the columns line up properly. Okay, 3 minus 2 gets me 1 with no problem, but 7 minus 8 I cannot make happen. I'm going to take my 37 that looks like and turn it into 20. And here's where I do write it kind of small, and 17. Do you know 17 minus 8? If you do, go with it and put it in there. If you don't, 2 more on the 8 to make 10, 2 more on the 17 to make 19. 9 minus 0 will get me the 9. Now I have an attempt to do 2 minus 5. That will not happen. So I go to my 42, this 4 and that little 2. And I turn it into 30 and 12. Now 12 minus 5, if you know that, you go ahead and do it. Put that digit right here under the 5. I don't have 12 fingers, so you might need to do this. 5 more there makes a 10. 5 more there makes 17, which is why I have a 7 down there. Now, 3 minus 1 I can do, so I will. That's 2, and 4 is untouched, so it's that. Go back and see where my comma was. It was after this 4, so it's after that 1, and it's after the 2. 42,791. The words than or from are very important. Than or from are followed by your starting point. Okay, I went through that in the lecture, I believe, but anyway, what's happening? When you see the word than, if I'm shorter than my brother, okay, we start with my brother and we make me shorter. Okay, if I weigh more than my brother, then we start with my brother and we make my weight go higher. But if you look at than or from, you're going to be able to initiate what's happening here. That means that when we're going from set 47, we're going to do subtraction, and we're going to subtract 19. Now we can set that up as 47 on top with the 19 there. Okay, 7 minus 9 is not going to happen. Turn the 47 into 30 and 17. 17 minus 9 if you know it. Add 1 to the 9 for 10, 1 to that to get 8. 17 minus 9 makes the 8. 3 minus 1 gets me 2, 28. Multiplication. 646 times 35. So 646 times 35. I line them up in their columns, and under each column will be that type of number column generating things that are going to add up to get my final answer for this. So when I go 6 times 5, I get 30. The 0 goes in, but 3 from 30 comes up here for the next digit. 5 times 4 is 20. 20 picks up 3 for 23. 3 gets parked in there, but I bring up the 2 from 23. 5 times 6 gets me 30. 0 right there, 2, 32 I get. Okay, so I have 32, 30. Now, under the first 6 is a 5, then a 0. Under this 4 is a 3, then a 3. Under this 6 is a blank space, and then a 2. 3,230 is not the whole answer. I now need to go to work using the 30. Some people leave a blank space here. Some people put an X there, but you're going to have to make sure that when you use this thing that looks like a 3, it functions as a 30. So I'm going to put that as a dashed 0. And now I have 3 times 6, which gets me 18. The 8 goes here, but from the 18 I have this 1, the 10s, right? 3 times 4 gets me 12. 12 picks up a 1 to make 13. 3 from 13 goes here, but I also push those 10 from 13 over here. 3 times 6 is going to get me 18. 8 plus 1 is 9, and then the 1, so there's the 9. No more digits to conquer, so I put my 1 there. No more digits for multiplying. Let's get towards 0 plus 0 is 0. 3 and 8 is 11, so there's the 1 for the units place, and there's a 10 for my 11, so I get 1 and 2 for 3, and 3 more for 6. No carrying here, and now 3 plus 9 gets me 12, so put the 2 there and carry 1 over, and I have this 22610. There are no decimals in this, but I do see that then I go 1, 2, 3 spaces, and then I put a comma, and that helps people recognize that 22 is your thousands, and then 610 is all of your 3 digits for the units. Now, how did I know about this? What I had here was if this is 30 and this is 600, I would get an 18 out in front and have 3 zeros. That would be 18,000. I went small on this and small on this to see about where I would land, right? And 18,000 is smaller than 22,000, but I didn't get this thing to be up in the 220,000s, and I also didn't have it land down in the 2,000s. So that's going to be helpful here to see that I landed in the right, what we call order of magnitude, and that will be helpful when we start to work on them with decimals as well. So 2288 divided by 13. The way we do it, long division, I want to keep emphasizing to you that long division involves erasing when your guess is imperfect. There's nothing wrong with an imperfect guess. What's great about a guess is learning what you can from it being imperfect. So 2 cannot divide by 13, it doesn't even have enough digits, but 22 can divide by 13, so there's only one of them in there. We don't have 26 or more here, so we have 1, which will create 13. 2 can't subtract 3, so I turn this into 10 and 12. 12 minus 3 if you know it. 7 more, 7 more. Anyway, that's a 9. So now we're looking to, that we just took care of the hundreds place, it's 100 and a couple other things coming. I bring down this 8 in the tens place, which is representing 80, but here it's going to function as part of 98. I'm going to get ready to erase because I know I'm going to make a mistake here, but 13 is kind of small. I'll treat it like a 10. And I'll take this 9, and I'll say 9 divided by 1. Let me try 9. Let me try 9. Let me learn from 9 if it's not perfect. 9 times 3 is 27, plus 2 for the 20s. 9 times 1 gets me 9, puts me at 11, 117. So that's too big. Not just by 17 like there was 100 for me, but a little bit more. So by 19 it's too big. That helps me know that 9 is too big a number for me to use. Now if I went 13 less, this would be 104, and I'd still have too much. So if you go back and try an 8, you're going to have to erase again, but I think 7 is going to get it for me. So now, having learned from that, I take this and I put in the 7. I don't erase everything, I don't throw the paper in the garbage. I now take this away, having learned, and you don't have to erase it, you can leave it there. But I got the 9 too high, the 8 wasn't going to bring me low enough, I'm going for 7. 7 times 3 is 21, here's the 2 for 20. 7 times 1 is, 7 times 1 is 7. Pick up the 2 to get 9, and there's where my 91 will come from. 9s will cancel, but 8 minus 1 will get me 7. And now, that's in the 70s position, because this last 8 has to come down and complete my creation of 78. This will be the last digit of whole numbers. I have 170 something. I'm going to see what I've got there. Let's see. That's pretty close. That if I tried 7 divided by 1, I think I might get a 7, but it turns out that if I go for a 7, I'm going to get another 91. I can see that I used the 7 before it made 91, and that's too much. So let me try 6 for that reason. 6 times 3 is 18. Put the 1 out there from the 18's 10. 6 times 1, 6 plus 1 for 7. Subtraction, perfect. No remainder, so I don't write R0, I don't write 0 over 13. Here I have just 176, and I don't need to add decimals. These are all features that come up later. You can create a remainder, use it as part of a fraction to get a mixed number. You can continue into decimal digits. When we deal with the decimals, we either go until we do get a 0 remainder or we get a repeated pattern, which is guaranteed one of those two things will happen. Some will take a while, but it's guaranteed to happen. We'll come back now in a little bit and work on the rest of the work for this. Another one I want to do with long division. 4,592 goes under the fraction, set up in long division format under the, I should say, division sign. Here's what goes on. 4 doesn't even have enough digits to handle 85. 45 is not large enough to divide by 80. So I'm going to start over this 9 in what is the tens place. So my digit, the biggest digit that will have a non-zero value is in the tens position. And now I have 45, or 459 divided by 85, which I don't exactly know what that is. 85 is like right in the middle between 80 and 90, so I'm going to treat this like an 8, and I'm going to say 45 divided by 8. 5 will give me 40, 6 will give me 48, so I'm going to try a 5. Maybe it's good, maybe it's not. 5. We'll see. 5 times 5 is 25. 2 from the 20. 5 times 8 is 40. That gets me 42. So I put my 42 here, and we go and see 9 minus 5 is 4. 5 minus 2 is 3. 34 is positive and smaller than 85. The 5 is correct. So now we move over to where we have a 2 in the units place, and we bring in the 2 to make 342. Now remember, I'm treating this like an 8. It's right between 80 and 90, but I'm only going to use the first two, 34 divided by 8. I know if I use a 4, I get 32. If I use a 5, I get 40. I'm going to try a 4 for 32. So I'm going to go with 4 right here. 4 times 5 is 20. So I put my, sorry, that's 2. So 4 times 5 is 20, and I put my 2 there from the 20. 4 times 8 is 32. So I get 34, and I come in here. Now, what do I do here? Well, 2 minus 0 gets me 2, 4 minus 4, 3 minus 3, I don't have to write. I have 2 left over. What that means is I got 54 full cycles of the 85 and 2 left over. I'm not going to write R2. I'm going to put my 2 over 85. And that's what I'll have. Let's take a look at how that works. 54 times 85. 54 times 85. 4 times 5 is 20. Here's the 2. 4 times 8 is 32. Pick it up for 34. So I get 340 from that. Now I put my 0 in here. 5 times 5 is 25. Here's the 2 for the 20s. 5 times 8 is 40. We get 42. And so I add those for 0. I add those for 9. I add those for 5. And I add those. So I got 4590. Right? Remember, I had 2 extra. So I add the 2 remaining ones on, and I get 4592, which is what I started with. And that always happens, that when you do long division, if you multiply the quotient that you find by the divisor, the number you divided by, that gets you almost all the way there. And if it gets you all the way there if there's no remainder, add on the remaining pieces to get all of what you started with. This says divide 308. It's actually written as a word problem like that. Some people are like, words, get away. Nope, not doing it. You can't do that in this class, okay? You're not going to succeed enough if you abandon all hope on word problems. You don't have to be the world's best word problem doer, but you've got to give them some work and try and make some progress. This is taking 308 to work with and divide it by 12. So 3 is too small to divide by 12, but there are some 12s and 30. So if I do 3 divided by 1, then I think I might get 3 of them. And I'll do 3 times 2 is 6, and 3 times 1 is 3. 36, it's going into the negative. So what happens there is, I learned 3 above the 0, 3 in the tens place is too high, let me go with a 2. So above the 0, I'm going to now work with a 2 and some confidence in being correct. 2 times 2 is 4, 2 times 1 is 2. 0 minus 4 is not going to happen. But if I turn the 30 into 20 with 10, 10 minus 4 should get me 6. 68 is formed when I bring down the 8. So I learned last time that if I did 6 divided by 1 and went with a 6, that might be too high, so I'm going to try a 5. 5 times 2 is going to get me 10. Put the plus 1 there from the 10. 5 times 1 is 5. We got 6. So here we have 8 as the remainder. 68 minus 60 gave me 8, which is positive and smaller than 12. So now I will put that up over here as 8 over 12, which can then have people saying it's 25 divided by 4 divided by 4 and 2/3. But this is the number group that I want to work with. I want to take the 25 I just made times 12. See what that gets me. Remember, I had a remainder of 8. I don't want to go to the 2/3 and say, oh, there's my remainder. My remainder was 8. So 2 times 5 is 10. Here's the 1 from 10. 2 times 2 is 4. Pick it up for 50. Okay, now 0, because I'm starting in the tens position. 1 times 5, 1 times 2. This is going to get me zeros add to 0. This makes a 10, so I make that 300. Plus, I had an extra 8. And when I put the 300 and the 8 together, I get the 308 we started with. So this will be the answer fully reduced. And now I want to do 3 times. I want to take 7176 and I want to round it. And rounding is done as follows. If you want to round to the hundreds, you want to have a number in the hundreds that's probably not 0. Occasionally it will be 0, but behind that you want all zeros. So the hundreds place is right here. So I'm definitely keeping the 7. And behind the 1 that's going to possibly switch to something else, I'm going to put 2 zeros. Now I look at what this has me focusing on. I look at what this digit that I might change up or might leave as it is. You don't take the 1 down lower to 0. But 17, closer to 20? Or is it closer to 10? 17 is closer to 20, so I want to make those 2 things turn into 20. And I get 7,200. So the digit that may change or may stay the same was this 1, and behind it will be all zeros. Now it wants me to do the 10s. So what happens here is the 7 and the 1 are staying there. I'm focusing on this 10s where the 7 is, and behind it will be a single 0. I am looking here at 76. 76, do I think of 80 or do I think of 70? 76 is closer to being 80. So I wind up with 7,180. Now this, they want me to round it to the nearest thousands. So I have, I'm looking at the 7 when I look at this 71. Now what I have behind it is 3 zeros, where the 1 is a 0, where this second 7 is a 0, and where that 6 is a 0. But 71, does that seem more like 70 or more like 80? And that seems more like 70. Right, so these 2 digits, the old 71 round to 70, and I wind up with 7,000. What you're doing when you're rounding off is you are focusing on the digit that they talk about to possibly go up by 1 or possibly stay where it is. And then it depends on the digit that follows it. 17 is like a 20, so those 2 make a 20. The 0 is automatically going to be there, right? Because you know zeros are coming behind it. The 76, more like 70 or 80. And then finally 71, more like 70 or 80. And we make those kinds of replacements. The tricky part for people is 5s. Most people do know that 0, 1, 2, 3, and 4 go down, and 9, 8, 7, and 6 go up. But 5 actually goes up, and here's why. Ready? With the 9, we got the 0. With the 8, we got the 1. With the 7, we got the 2. With the 6, we got the 3. With the 5, we got the 4. You get one of each. 5 winds up here, going up. 0, 1, 2, 3, 4, they drop off, they don't push it up. 5, 6, 7, 8, 9, they do push up. 5 is going up. 5 is not in the middle. 5 is a push up. And that's our mixed practice.